Welcome to The Explainer. I am so excited you're here today because we are going on a massive zoomed out journey. We're going to start right in the weeds, looking at the absolutely staggering, lightning fast speeds of the newest AI models dropping in mid-2026. Then, step by step, we're going to zoom out to the mobile ecosystems they live in, the edge hardware that actually makes them tick. And finally, we'll look all the way out to the macro horizon of quantum computing. I know, it's a massive scope, but I promise you, by the end of this, the whole shebang is going to click together perfectly. Right off the bat, we have to ask, how fast is too fast for AI? You know, for the last couple of years, we've been totally obsessed with AI getting smarter, right? But as of June 2026, the entire conversation has suddenly, violently pivoted to speed. And we really need to set the context for the most mind-blowing AI breakthrough of the month, because it fundamentally changes how humans and machines interact in real time. Okay, let's dive into this. Over 1,000. That is the number of tokens per second that Google DeepMind's new experimental text model, which is called DiffusionGemma, can generate on a single NVIDIA H100 GPU. Over 1,000 tokens a second. Early testers, like the developer Simon Willison, have already confirmed speeds of over 500 tokens a second just using NVIDIA's free cloud API. It is literally so fast that human eyes cannot track the text as it appears on the screen. It's just a blur. But how did Google actually pull this off? Well, this brilliantly illustrates the architectural shift. See, traditional frontier models are what we call autoregressive. Think of an autoregressive model like a really fast typist on a typewriter, clacking out one single letter or token at a time in sequence. It's entirely linear. DiffusionGemma just throws that completely out the window. It uses a text diffusion process to generate entire blocks of 256 tokens simultaneously. It's exactly the difference between a typewriter and a printing press stamping a whole page at once. This architectural leap makes it up to 4 times faster than standard models. Now, you might be wondering, why does this matter to us? Well, DiffusionGemma is a 26 billion parameter mixture of experts model, which means it dynamically routes tasks to specialized subnetworks for maximum efficiency. It only uses about 3.8 billion active parameters during inference. And here's the kicker. It's totally open source under an Apache 2.0 license. The absolute crucial takeaway here is application. With this kind of speed, local, real-time AI agents finally become usable. Think about code infilling or inline editing, where the AI is predicting and writing whole blocks of text while you are actively typing with absolutely zero lag. It literally removes the friction between human thought and machine execution. It's a real game changer. Section 1. Google's multimodal ecosystem. If we zoom out from just DiffusionGemma for a second, we have to look at Google's massive coordinated ecosystem rollout, because they are absolutely overwhelming the market right now with specialized models. Just walk through this timeline with me. Back in December 2025, they dropped Gemini 3 Flash. By April 2026, we got the open-weight Gemma 4 models and that incredible Nano Banana 2 image generator. And now, in June 2026, they've launched Gemini 3.5 Flash, which is highly optimized for complex agent workflows, and their new flagship multimodal model, Gemini Omni. This isn't just a slow drip of updates, right? It is a rapid-fire deployment of highly specialized tools covering text, image, and video, all within 6 months. Now, what's really interesting about this slide is how Google is packaging these models for creators. Powered by that Omni model, Google just launched a tool called Google Flow. It processes video, audio, and images simultaneously. But the absolute game changer here is the natural language video editing. As the source materials highlight, you can feed Flow a video of a boy looking at a butterfly, and by just typing plain English into a text box, you can change that butterfly into a bee or maybe a swarm of fireflies without having to reprompt the entire scene. You can even save consistent characters to a library and drop them into new scenes instantly. It is completely reshaping the creative and filmmaking industries as we know them. Section 2. The Apple-Google AI Alliance. But listen, having the best models is only half the battle. You absolutely need distribution. And here we see a major realignment in tech. In iOS 27, Apple has secured a massive $1 billion per year deal to use a custom 1.2 trillion parameter Google Gemini model as the system default for Apple Intelligence. However, to remain impartial and actually offer users the best tools, Apple introduced an extensions framework. This basically dismantles any single company's monopoly right on your phone. If you ask Siri a general query, it defaults to Gemini. But if you need complex, creative writing, it dynamically routes to OpenAI's ChatGPT. Need advanced document analysis? It routes to Anthropic's Claude. And to maintain absolute transparency, each model speaks to you with a distinct synthesized voice, so you always know exactly which AI is answering you.
Section 3. Hardware powering the edge.
Okay, it's vital to understand that none of these local models and literally none of this dynamic mobile routing is possible without physical silicon. We are essentially watching a silent war happen beneath our keyboards. To run massive, lightning-fast models locally, you need incredible edge computing. NVIDIA is pushing hard into high-end Windows laptops with their RTX Spark platform, pairing an ARM architecture with an integrated Blackwell GPU. Meanwhile, Intel is aggressively targeting the ultra-thin PC market, think Dell XPS and MacBook rivals, with their Core Ultra Series 3, utilizing their brand new 18A manufacturing node. The software is obviously getting faster, for sure, but it's these silicon platforms that are actually carrying the weight.
Section 4. Open models and agentic swarms.
Which actually leads us to a pretty interesting paradox. We have incredibly fast models, right? And powerful new hardware. But when we transition to the developer landscape to build autonomous AI agents, we hit a brick wall. This represents the new SWE Marathon benchmark, which tests frontier AI models on 20 multi-hour software engineering tasks. And just look at that success rate, under 19%. 81% of the time, they outright fail. So the crucial point is, despite extreme speed, a single AI agent still gets winded, just like me after a single flight of stairs, honestly. Over the course of a multi-hour task, it simply loses the thread, forgets the context, and breaks down. The industry totally knows this, and that's exactly why they're adapting. Read this quote from the recent NYC AI Engineering Code Summit. A pivot from single large context AI agents to multi-agent ant swarms for reliable coding. Instead of relying on one super smart but easily distracted agent, developers are shifting to swarms of smaller, highly specialized agents that constantly double-check each other's work. It's like a giant puzzle where everyone holds one piece. It's so effective that industry veterans like Steve Yeague are forecasting the total demise of traditional IDEs, the standard software coding environments, by the end of 2026. The swarm just completely takes over the heavy lifting.
Section 5. The quantum computing horizon. So we've gone from the micro speed of text tokens all the way out to developer swarms. Let's zoom out one final time to the true macro horizon and the future of pure compute power. Just let this number sink in for a second. $10 billion. Following a $1 billion federal award to build a U.S. quantum manufacturing foundry, IBM has announced a massive 5-year investment commitment of $10 billion dedicated purely to quantum commercialization. This isn't theoretical research anymore, guys. This is the staggering scale of capital required to build the infrastructure of tomorrow.
And all of that money, it's aimed squarely at this target, quantum Starling. This is IBM's massive ambition for the year 2029. They are building a large-scale, fault-tolerant quantum computer designed to operate with 200 logical qubits and execute up to 100 million quantum operations. A machine of this incredible scale aims to unlock practical applications across national security, drug discovery, and advanced materials that are, frankly, completely beyond the reach of classical computers. Which brings us to our final slide and a really provocative thought I want to leave you with today. Right now, we are absolutely amazed by DiffusionGemma, printing thousands of tokens a second, and agent swarms building software on new edge hardware. But what happens when the simultaneous block generation architecture of these AI models collides with the fault-tolerant astronomical compute power of a machine like quantum Starling in 2029? If this is what speed looks like today, what will the speed of thought look like in just 3 years? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you next time.